Good afternoon, my dear students. Yesterday we have completed a pair of linear equations in two variables chapter. See, that chapter contains 6 exercise up to 3.6. The second part of that 3.6 exercise was a verbal problem. Those verbal problems are very important. Already I have said about that. Then yesterday we have announced that to bring your fair notes as well as the July monthly test papers. But the 70% of the students were not responded. So it is very sad to say about your activities in nowadays. You are not having any other work except related to studies. You just recall yourselves that you are a 10th student. What your responsibility is now. At least you don't do any homework. Just write down in the notebook what we are explaining, what we are solving, what we are doing about that. It is very pity to say that only 30% students are active in studies. Please try to understand your position. Then next week the schools will begin. Then your all activities will be wide open. Let us see what will happen that day. Now, today I will start the chapter, the triangles. You know the triangles chapter comes under the geometry section. Before studying these triangles, we should know about the similar figures and similarity of triangles, how the similarity is defined, all those things. You know, the similar figures means in general what looks alike. For example, if one board is sitting in front of you, the another board of different length will appear like that. So both the boards will appear similar. All the congruent figures are similar. You know, you have learned the congruency in the 9th standard. That congruency, that means the congruent figures, that figures having the same size and same shape are the congruent figures. Like that, we have to define the similar figures. Similar figures means the figures having the same shape. The figures having same shape. See, we are not considering here any size. Not necessarily with the size of the figure. Okay? The figures having the same shape, or it may be of same size or it may not be of same size. So, but if the figures are look alike, we may call those figures as similar figures. Okay. Now I have written the theoretical definition related to the similar figures, what we are going to learn in this chapter. So write down those points, then let us continue the exercise related to this theoretical part. Similar figures, the two circles of different radii are also similar figures, the two squares of different lengths also similar figures, two congruent circles are also similar figures. Then the polygons of different sides may be similar if and only if their corresponding angles are equal and the corresponding size of the corresponding angles are equal and the corresponding sides are in proper proportion. proportion, their corresponding sides are in the same ratio or same proportion, then only we may call those polygons are similar ones. See, two polygons are of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. So this small topic, with this small topic, we have one small exercise. Okay, let us solve that. First you write down this whatever I have written on the board. Okay, take your own time. See, this one is the exercise related to the triangles. First exercise, exercise 2.1. Fill in the blanks using the word given in the brackets. They have given two words in the bracket. We have to insert the proper word so as to have the proper statement. All circles are, see, all circles are, the word given is common, similar. See, we never find all the circles are congruent. There may be variation in the radii, then there may be the size variations. That means radius variation is nothing but that is the size variation of the circle. So all circles are similar. That means they look alike. That is, the all circles are similar. Similar is the correct answer for first one. Then all squares are not congruent. Why? Or because they may have the different length, they may have different sizes. So similar, all squares are similar. Then the third question, all triangles are similar. They have given us the two triangles, isosceles. Suppose if we consider that isosceles triangle, okay, let us think that two sides are equal. Then what about the third side? Then what about the third angle? The angle may have variation, but in equilateral triangle, all the angles are equal. 2, that is 60, 60, 60. So that we may also call as equiangular triangle. That means the equilateral triangles are similar. All triangles are similar, which are equilateral. All equilateral triangles are similar. Okay? All circles are similar, all squares are similar, all triangles are that equilateral. All equilateral triangles are similar. Next, fourth question. Two polygons of the same number of sides are similar. See, I have given in the notes. That means their corresponding angles are equal. Their corresponding angles are equal. Then their corresponding sides are proportional. Their corresponding sides are proportional. Okay, this much is the first part of the first question. Okay, write down neatly. See, give two different examples pair of similar figures. Similar figures which are look alike, that is similar figures. All equilateral triangles are similar figures. All equilateral triangle, because all sides are proportional and all angles are equal. Then all squares are similar figures. All squares, all angles are equal. The corresponding sides related to each other are proportional. Then non-similar figures, that is a parallelogram and a trapezium. Parallelogram and a trapezium means in the parallelogram opposite sides are equal and parallel, but in case of trapezium opposite sides are only parallel, only one pair of opposite sides are parallel. Then a square and a rectangle. In a square all sides are equal, but in a rectangle opposite sides are equal, even if the angles are same. That is, that the rectangle contain 90 degree, then after that square contain 90 degree, but in proportion both are different. Okay, now write down this. See, state whether the following quadrilaterals are similar. See, two quadrilaterals they have given. One is a parallelogram, another one is a square. Okay, they are looking like that. That is parallelogram type of quadrilateral. See, two polygons are similar if and only if their corresponding sides are in proportion or their corresponding angles are equal. Okay, say let us check the proportionality. Proportion SP by AD, corresponding side, that is 1.5 divided by 3, that is equals to 15 by 30. 15 ones are 15 twos are 1 by 2. Okay, then QR divided by BC, QR divided by BC, that is 1.5 divided by 3 equals to 15 by 30, that is equals to 1 by 2. Then PQ by AB, PQ by AB, that is 1.5 divided by 3, that is 15 by 30. 15 ones are 15 twos are 15 ones are 15 twos are, that is 1 by 2. Then I want another corresponding side, SR divided by CD, 1.5 divided by 3, 15 by 3, 30 equals 15 on the 15 to 1 by 2. Say, in this case, the corresponding sides are proportional. The corresponding sides are proportional because we got the corresponding sides are proportion. 1 by 2, 1 by 2, 1 by 2 we got. But another aspect of this polygon is corresponding angles should be equal. Corresponding angles, say corresponding angles. Corresponding angles. See, Angle B is not equals to angle A. Angle Q is not equals to angle B. Angle S is not equals to angle D. Then angle R is not equals to angle C. That means angle A, angle B, angle B, angle A equals to angle B equals to angle C equals to angle D equals to 90. All the angles of rectangle are 90 degree. That square is 90 degree. So even if the sides are in proper proportion, but the corresponding angles are not equal. Say, by observation itself we can predict that both the diagrams are not similar ones. Okay, so your answer is quadrilaterals are similar or not? No, is the ultimate answer for this diagram. Okay, draw the diagram and just write below the diagram in all things, but not necessary to mention whether they are similar or not in this way. Simply by observation, and the corresponding angles are not equal, therefore the figures are not similar. But to make more clear, I have shown that even if the sides are proportion, the corresponding angles are not equal. That is why the figures given are not similar ones. Okay, write down. Tomorrow we shall continue from the first theorem of the SSLC syllabus, that is basic proportionality theorem. Don't miss that one. That is the basic theorem for SSLC standard with respect to geometry. So very useful one, don't miss it. Today this much is the sufficient. Make one king size fair notebook of unruled without fail. Thank you.